All right, so we are back for our final lesson of Unit 2. Unit 2, Lesson 7 on quadratic optimization, which is our calculator / word problem section. So we're going to do problems that require us to think about optimization. We're going to optimize mostly areas or dimensions that are going to create the biggest possible area of whatever we're creating. We're going to solve things either algebraically, or you're going to use your calculator and do it using a graph. But sometimes some of you might just want to do it algebraically. I'll demonstrate that. Graphically, I actually won't be able to demonstrate because I can't bring up my calculator and show you. So you'll have to refer back to the other lesson and video if you need to, or ask your teacher questions, because it might be faster to use your calculator. Unfortunately, I just won't be able to show that to you. Remember, you are going to round your answer to 3 decimal places, or you can just truncate it, meaning you don't have to round up or down. You can just see the first 3 decimals and write whatever those first 3 decimals are for your final answer. But you should be in fix 5 or 6, because if you get a numerical value from your graph, you're going to have to write all 5 decimals or 6 decimals down into the equation until you get your final answer. And then your final answer should just be truncated or rounded to 3 decimal places. Again, might be a little confusing, so ask your teacher. All right, our first example. It says a homeowner has just enough money to purchase 87.5 feet of material for his backyard to create a fence. He wants to use this material to enclose a rectangular garden with the largest area possible. So again, optimization, we're trying to create the largest area possible. The homeowner plans to use the back of his house as one side of the garden, so he really only needs to fence 3 sides. If X represents the width of the garden, label the diagram below. So you can see we only have the 3 sides here. So this right here, the missing side, is then representing the house. So this is the back side of the house. And then it says, let X represent the width of the garden. So some of you might be wondering like, which dimension is the width? I mean, I'm with you. I'm going to call this the width. So these 2 sides are the width. And this is the length down here. So we'll call that L. So what do you know? If you have 87.5 feet of fencing, well, your fencing is going to be put here and here and here, and we have 87.5 feet to do that. So what are we going to have to do? Well, hopefully you're seeing, okay, that's just the perimeter, except I don't need to do the blue part because that's the house. So it's 2x plus the length equals 87.5 feet. So that represents the perimeter around the garden that we're going to create. Now, it says write an equation for the area of the garden as a function of the width. So I'm going to do the area with respect to the width. Well, remember we said the width is our x value. Well, the area is just length times width, which is L times x in this case. Except we can't have 2 different variables representing an area. We need to do everything with regard to x. So I'm going to go up to this equation up here. I'm going to isolate my L. So L equals, I'm going to move my 2x to the other side. So I get 87.5 minus 2x. So now instead of L here in the equation, I'm going to have 87.5 minus minus 2x. Right, so this is going to equal 87.5 minus 2x times x. This is my length, this is my width, and length times width equals area of a rectangle. So to color coordinate it, everything, we're just going to have the width times the length, and here we have the area formula. Now it says, what is the maximum possible area of this garden? And then finally, what are the dimensions of the garden that would create the maximum area? Well, personally, I'm hoping you can look at this function right here, a of x equals this, and I'm hoping you can just think of a graph. So I'm going to sketch the graph up here as much as I possibly can, because I think that's helpful. I'm very visual, So I want to always kind of think about graphically what this means. So what is the x representing? Hopefully you're saying to yourself the x represents the width, right? And the width is in feet. What is the y value representing? Well, that's just the area with respect to the width. So that's also in feet. And so what do we know so far? Well, we have two zeros, right? We have a 0, it's in factored form. I have a 0 at 0, and I have a 0 at 87.5 minus 2x equals 0. So I'm going to take half of 87.5, and that's going to be my other 0, so that's at 43.75. So it's a parabola, right? If I were to distribute this, I would get negative 2x squared plus 87.5x, negative 2x squared plus 87.5x. So it's a negative parabola, so that means it's going to open downward. And here's where my vertex is. So I don't know what my vertex actually is, but I could calculate it. And if it's asking me to find the maximum possible area, then what am I trying to find? I'm trying to find the y-coordinate of the vertex, right? This is the maximum possible area up here. So it's the y-coordinate of the vertex. So how can I find the y-coordinate of the vertex? Well, you're either going to grab your calculator and you're going to put this function, x times 87.5 minus 2x, into your calculator, graph it, and then find the maximum. Or you can just solve for it, right? If we are at 0 to 43.75, I can find the average to find my x-coordinate. My x-coordinate would be 21.875. You can plug that into your calculator. And then I'm just going to do the area formula, so I'm just going to plug that in. So it's 87.5, or sorry, we can just put 21.875 times 87.5 minus 2 times 21.875 again. So when you calculate that, what do you get? I'm just calculating it now. You should get 957.031 feet squared. Again, you can do that algebraically like we just did because you have your calculator. Your calculator's still going to help you find the answer algebraically. So this is the maximum possible area, right? Or you can do it graphically up here, plug that into your calculator, into f of 1, find the maximum, continue that way. Oh, sorry, I had to squeeze all of this onto one page so I could answer all the questions. So the second, letter D, says, what are the dimensions of the garden with the maximum area? Well, dimensions are your length and your width. Right, so what do we already find? We just found, right, we found the corresponding width that is in association with the maximum height. So the width is 21.875 feet, and then I would plug that value into here, right, to calculate, or into here to calculate the length. And so when I plug that in, I'm going to get 87.5 minus 2 times 21.875, and whatever this answer is my length. So that was 43.75 feet. Again, it's hard. I can't show you how to do these calculations, but you should be grabbing your calculator. You should be trying it on your own. If you're not, that is going to make your test and your quiz be a little bit challenging. So make sure you are practicing how to use your calculator. Otherwise, you'll be really slow, and that will be difficult for you to manage on the assessments. Okay, question number 2. It's pretty much the same question as number 1, except instead of putting your garden against the house, you're just moving it out. It says, let's say the homeowner decides that it's better to have the garden out in the sunshine and not right up beside the house. He will now need to use 87.5 feet of fencing to enclose 4 sides of the garden. So we have our width, and we have our length and our length. So this time we have twice the width plus twice the length equals 87.5 feet. right? And so then that means instead of isolating L, we need to solve for L, right? So I move the 2x to the other side, so 87.5 minus 2x equals 2L. And then I divide each side by 2 to isolate L. So L equals, I don't know what happened there, sorry. L equals 87.5 divided by 2 minus x, 2x divided by 2, which is just x, right? Or what we found out before was that 87.5 divided by 2 is 43.75. So this is now our x. So it says label the diagram. Okay, we did that, XXLL. Write an equation for the area of the garden as a function of the width. So area equals length times width. But area with respect to the width is x. So that's going to be length, which is 43.75 minus x, times our width, which is just x. So this is our equation. This time, use your calculator to solve for this, or you can do it algebraically, but I'm going to give you the answers so you have it. So what is your max area? Again, I want you to pause. I want you to do it on your own, and then you can come back and check out the answers. So pause, try it on your own, come back, check out the answers. Okay, so hopefully you paused and now you're just looking at the answers. So when you plugged this equation into your calculator, or when you did the vertex and you found the vertex, these are the answers you should have gotten. So when you found the vertex over here, here's my graph here on the right hand side. Sorry, I'm trying to get my highlighter. Here's the graph on the right hand side, right? So when you had, you have a 0 at 0, you have a 0 at 43.75, you should have been able to find the maximum there at 21.875 and 478.516. So what is the y value representing? It's representing the area. So the maximum area was 478.516 feet squared. Again, area is two-dimensional, so you need to have your units there, feet squared. Then it says what are the part C was what are the dimensions that would yield that area. So we have 21.875 feet by 21.875 feet. And sorry, I got ahead of myself here. These are not D and E. This is E and F, and we'll talk about D because I think it's a little more important to talk about that one. So your practical domain is, what's going to yield your possible areas. So that's going to be from 0 to 43.75. Really, we should have rounded on both of those because we shouldn't have an area of 0. We really want the area of the garden to exist, so it should be rounded, exclusive, and exclusive. For the practical range, again, we really don't want to have an area of 0 or else the actual garden wouldn't exist. And then you would go to 478.516, and that would be inclusive because you could have a maximum area of 478.516 feet squared. So L, oh dear. Now on this page, we'll just do the actual what do you do for part D. So I ran out of space. I put the answers to C and E and F on the other one, but this is like, what do you do? How do you find area, or sorry, what dimensions will you have if you want an area of 300 square feet? So this you have to use your calculator, and you would use your graph. So you would graph into your function 1, the x, and the 87 or 83 point, sorry, I'm looking at my, 43.75 minus x, you would graph that, so you'd have your two zeros here, and this would be your function. And remember, it had a maximum of 478.516, so you should have all this graphed on your paper, potentially, if you didn't do it algebraically. Then what you're going to do is in f sub 2, you're going to put in 300. And you're going to sketch where it's 300, and it should be a horizontal line, and it's going to intersect this parabola at two different locations. So those two different locations are, this first one was 8.514, and the second one was 35.5 35.236. So it says, what dimensions would yield a garden with an area of 300 square feet? Well, you're either going to have an X value or a width of 8.514 feet. And then if you plug that into the equation, guess what it gives you? It gives you 35.236 feet. Or you could reverse those dimensions, so you would have gotten 35.236 feet for your width, and then your length would be 8.514 feet. So, yeah, it's either a rectangle like this, or it's a rectangle garden like that. Yeah, so it's either long or it's wide, I suppose, however you want to say it. So again, these little multiplication looking symbols mean the word by. Notice, so it's 8.514 feet by 35.236 feet, or 35.236 feet by 8.514 feet. Example 3 is what we've been doing. I'm not going to go through this one with you, but we can talk about how to set it up. But I would encourage you to just try it on your own and not rely on me to set it up. If you want to just wait, we can set it up together and then you can do the rest on your own. So it says an animal corral is to be formed by fencing a rectangular area in an open field. So I know I'm going to have a rectangular area in an open field. The corral must also be split in half by a fence in order to separate the cattle from the chickens. So we have cattle on one side and we have chickens on the other. Given that you only have 200 feet of fencing material for the corral, what are the dimensions of the corral with the greatest possible area? So I want to maximize the area. And so I need to have this dimension, this, and this. That's all three. These are all going to be filled with fence, right? And they're the same dimension. So I have an X, an X, and an X. So that's 3X. Then I'm going to have this entire length and this entire length. We can call it length and length. So 3x plus 2 lengths equals what? Well, we only have 200 feet. So remember your area, right? My area is just length times width. X is my length, X is my width, and L is my length. So it's just X times L. So I have to take this L over here, I have to solve for L, so it's 200 minus 3x, divide by 3, divide by 3. So my width is just x, and my length is 200 minus 3x all over 3. So we've set up the equation. You can read the rest, try to answer it, but that is what we would have there. All right, I'm going to do example 4, not example 5. They're both very similar, so I'll just explain one, and then you will be on your own to do number 5, and you can check your answers on the answer key. So this question is a little different from what we were doing. It says the yearbook staff at Riverdale High School is in the process of mounting photographs from the homecoming activities for the yearbook. Each photo will have a uniform border around the outside and will be mounted on an 8.5 by 11 inch page. So this is the entire page, and this width or length here is 8.5 inches, and then this dimension up here is 11 inches. And I only know that because obviously the one on the bottom is smaller than the one going up and down. So it's 8.5 inches by 11 inches. Okay, let's go back and talk about what this uniform border means. Well, part A says if X represents the width of the border, label the diagram with the dimensions of the photograph. So the border has to be uniform, means it's the same on all sides. So the bottom part we're going to call X. We're adding X inches on the bottom, X inches on the top, X inches on the right, and X inches on the left. Okay, well, we are trying to figure out the area of the photograph. So the photograph is in here, right? It's this white area in the inside. So how can I find the area of the photograph? So we need to find the area with respect to one variable, which is going to be x in this case. Well, originally you can see this width across the bottom, or length, whatever you want to call it, is 8.5 inches. So if this is 8.5 inches, the green portion, I have to subtract x from the right-hand side and subtract x from the left-hand side. So this new dimension on the inside is not 8.5 inches, it's 8.5 minus 2x, right? I had to subtract x from the right and then subtract x from the left. So one of the dimensions is 8.5 minus 2x. Now do the same thing with the 11 inches, right? I have my 11 inches up the side here, right? This is 11 inches, then I subtract x, So what will the dimension be on the inside but just this portion here, right? I subtract x. So hopefully you can see that this inside portion is just 11 minus 2x. So our other dimension is 11 minus 2x. So I have 8.5 by 2x and then 11. Sorry, 8.5 minus 2x and then 11 minus 2x. All right, so that's how we express the equation. Then it says if the border is 3 inches wide, that means if x is 3, what is the area of the photograph? Well, we can just plug in a of 3, so you should be able to do that on your own. I would encourage you to pause, try that on your own. You should get an answer of 12.5 inches squared. So again, try it on your own. I don't want to do that for you. You should do it. And then lastly, it says if the editor wants the photograph to have an area, so this time they're giving you the area. So the area is 56 inches squared. How wide should the border be? So this is where you have to use your calculator. You're going to graph, right? So you're going to have your two zeros. Here's a 0 and here's a 0. When we multiply negative times negative, it's going to be positive. So we know our parabola should be opening upward. And I'm going to have a y-intercept, so it's going to look something like that. We're going to have two zeros. What do those zeros mean? That's not really what we're after. We're after when will the area be 56 inches squared. So after you plug in this into f sub 1, f1 of x, then you would plug this in to f2 of x. You would use your points of intersection to find what x coordinates are associated with that, and then you're going to get your answer. And again, you can check that on the answer key. So actually, I'll just put it here. You should check it yourself, but this x value is 1.80082, and this x value is 8.668. So at least you know if you got the x values correct. So again, 1.082 and 8.668. It says how wide should the border be? So obviously this one is a little bit bigger than 1 inch. This is almost over 8.5 inches. So can we have a border that big when the entire paper width is 8.5 inches? No. So the border would have to be 1.082 inches. Again, don't rely on me for these answers. You still need to go through the work. You still need to plug it into your calculator. You still need to make sure you know what you're doing. So please do that. And then, of course, ask your teacher if you're having any difficulty. I hope this helps. It's pretty difficult to explain it and not have the calculator showing. So again, go see your teacher. Come see me if you want any follow-up with how to use the calculator. Bye.